Today we will discuss two very important theorems related to triangle. First one, angle sum property of a triangle, which is called in short ASP of a triangle, and second one, exterior angle property of a triangle. So let us start with this angle sum property of a triangle. What is the statement of this theorem? According to this angle sum property of a triangle, the sum of all the three interior angles of a triangle is always 180 degree. According to this angle sum property of a triangle, the sum of all the three interior angles of a triangle is always 180 degree. Dear students, whatever the type of triangle, that doesn't matter. Triangle may be scalar, triangle may be isosceles, triangle may be equilateral, triangle may be acute angled triangle, triangle may be right angled triangle, or triangle may be obtuse angled triangle. But sum of all the three interior angles remains always 180 degree. That is the statement of this theorem, angle sum property of a triangle. For an example, if we have a triangle A, B and C. Here we have these three interior angles of a triangle ABC, which are angle A, or you can say that angle BAC, angle B, or you can say that angle ABC, and angle C, which can be written like angle BCA. Sum of all these three angles is always 180 degree. For proving this theorem, there are four main steps, out of which three are compulsory and one step is optional. If we require, then only we write that step. First step of proving this theorem, that is given. In this one, we write everything which is given in question. Here only there is a triangle ABC that is given. So in given we write a triangle ABC. Second step, to prove. In this step, whatever we want to prove, that's right in this second step. Here we want to prove that sum of all these three interior angles is equals to 180 degree. So in this step we write angle A plus angle B plus angle C equals to 180 degree, or this can be written like angle BAC plus angle ABC plus angle BCA, that is equals to 180 degree. Third step, that is optional step, construction. For proving this theorem, if we require any additional construction, then only we write this step, otherwise we leave this step. In this theorem, we have to do some additional construction. So here we require to write this third step, construction. In construction, through this point A, through this vertex A, we draw a line parallel to BC. Here, let us draw a line, say XY, which passes through A and parallel to BC. So this one is written in our third step. Right here, draw a line XY through A parallel to BC. And now we come to our last step, proof in which we written the all steps how we can write, how we can prove this theorem. So now we come to our last step, proof. For our convenience, dear students, we mark these angles like this angle be A 1, this angle B that is 2, angle C that is 3, this angle XAB that be 4, and this angle YAC that is angle 5. So here we mark all these 5 angles as 1, 2, 3, 4 and 5. Now here, just see students, using the properties of parallel lines, here this XY parallel to BC according to our construction, and we treat this AB as a transversal. Here this XY that is parallel to BC and AB is a transversal. Therefore, according to property of parallel lines, this angle 4 equals to angle 2. Why? Because these are interior alternate angles, and interior alternate angles are always equal if lines are parallel. So, reason being the interior alternate angles. Similarly, again XY parallel to BC, and now we treat this AC as a transversal. Therefore, again angle 5 equals to angle 3, reason being the same, interior alternate angle. So here similarly, again XY parallel to BC, and now AC is a transversal. Therefore, angle 5 equals to angle 3, and the reason being the same, interior alternate angles. Say this be relation first, this be relation second. Now students, this XAY, since that is a straight line, therefore this whole angle becomes a straight angle. Sum of all these three angles, angle 4, angle 1 and angle 5, that becomes equals to 180 degree. So here students, now since XAY is a straight line, therefore angle 4 plus angle 1 plus angle 5 equals to 180 degree. And what is the reason? Reason being that is a straight angle. Let this be relation third. And now using relation first and second, in relation third, in place of angle 4, we can write down angle 2, and in place of angle 5, we can write down angle 3. So, using relation first, second and third, we can write down angle 2 in place of angle 4 plus angle 1 remains same, plus in place of angle 5 we can write down angle 3, that becomes equals to 180 degree. Or in order, we can write down this relation angle 1 plus angle 2 plus angle 3, that is equals to 180 degree, or we can say that angle 1 means angle A, angle 2 means angle B, and angle 3 means angle C, equals to 180 degree, or these angles can be written as angle BAC plus angle ABC plus angle BCA, that is equals to 180 degree. This is all about your angle sum property of a triangle, which stated that the sum of all the three interior angles is equals to 180 degree. And in last we can write here, hence proved. Okay students, this is all about your first theorem, angle sum property of a triangle. Now we come to second theorem, which is related to exterior angle property of a triangle. Exterior angle property of a triangle. What is the statement of this theorem? According to exterior angle property of a triangle, every exterior angle of a triangle is always equals to sum of interior opposite angles. So, according to statement, every exterior angle of a triangle is always equal to the sum of interior opposite angles. For this, first of all, let us consider a triangle. Say this again ABC is a triangle. As you know that students, each side of this triangle can be produced, can be extended in both the directions. For an example, this BC side that can be extended towards this right hand side, towards C, or this side also can be extended towards B, means in left hand side. Similarly, this AC side can be extended in downward direction as well as in upward direction. It means towards A as well as towards C. Similarly, this side AB can be extended in downward direction towards B or in upward direction towards A. For an example here, if we extended this BC side towards C up to a point B, we see that this produced side makes an angle ACB with its adjacent side in the exterior of triangle, and this angle is called exterior angle. And according to this theorem, according to this statement of exterior angles theorem, this exterior angle is equals to sum of interior opposite angles. Means this angle ACB, that is equals to angle A plus angle B. This interior angle makes linear pair with this exterior angle. So that is not interior opposite angle. Interior opposite angles are this angle A and this angle B. So here in given we have a triangle ABC in which side BC is produced up to a point D. Second step, to prove. What we want to prove here? That angle ACD, that is equals to angle A plus angle B. Third step, construction. Here we don't require any additional construction for proving this. So we leave this third step of construction and we come to our fourth step, proof. In proof, first of all, we apply ASP, angle sum property, in this triangle ABC. In triangle ABC, according to angle sum property, ATASP, according to angle sum property, angle A plus angle B plus angle C equals to 180 degree. Let this be relation 1. And now we use special type of adjacent angles which makes a linear pair. Here angle ACD and angle ACB, these two angles are adjacent angles which makes linear pair. So sum of these two angles is also equals to 180 degree. And angle ACB plus angle BCA, that is also equals to 180 degree. And what is the reason? Reason being linear pair of angles. And when we compare these two relations, first and second, since right hand side of both the relations is the same, therefore left hand sides must be equal. It means from relation first and second, angle A plus angle B plus angle C equals to angle ACD plus angle BCA. Angle C and angle BCA both are the same angles, are in opposite side of this sign of equality. One in left hand side, one in right hand side. Both have the same sign, both are the same angles. So these two angles are cancelled out, and here we have angle A plus angle B equals to angle ACD, or you can say that angle ACD equals to angle A plus angle B, and hence proved that every exterior angle is always equals to sum of interior opposite angles. So students, this is your exterior angle property of a triangle. That's all for today, students. Today we will discuss two theorems. First one, angle sum property of a triangle, and second one, exterior angle property of a triangle. In next session, in next class, we solve few questions based on angle sum property and exterior angle property of a triangle. Thank you very much and have a nice day.